Hi, my name is Neel, and today I'm going to be talking about merge sort. So, what does merge sort do? So, it's in the name. It sorts, right? But what's the special thing about it, right? It merges. What does this relate to? This relates to divide and conquer. This is a divide and conquer algorithm. So, what do you mean by divide and conquer? What you mean by this is that first you have to divide your problem into little subproblems, then you solve each of those subproblems, and then to round it all up with a final magical step, you put it all into the final answer. So, how does this mysterious merge sort work? So, first you have a list, right? And it has a bunch of values and you're trying to sort it. So, in the divide step of merge, it recursively breaks it down. So this list goes into two separate lists. And then these two separate lists break up into little smaller lists. And so on. Until each of these lists here are just one length long. Once this happens, there's nothing to split. So now we have to go back. So, what do? We take each of these tiny lists and then you go to a different method. It goes to a different place. And what it does is it merges these. But while merging these sorted lists, or in this case at the bottom, once it's broken all down to one list, there's just one element in it, right? Then you have to merge it. So obviously, when we have 1 and 1, we just merge it together, right? But if we have anything bigger, what we have to do is this. You have one list here, and then you have, so you have one list here, and then you have a second list here. Right? So now what we do is we take 2 pointers at the beginning of each of these lists. And to take a note, both of these sublists are completely sorted. But we just have to merge them in a way that makes a larger sorted list. So what are we supposed to do? Well, we have these 2 pointers here, right? And now we compare both of these. So which one's greater? 1, right? So we put this in the end list. And now this pointer goes on to the next one. Now, which one's bigger, 2 or 3? 2, right? And so this way, we keep on going. Right? So that's 4, then you have to go over here. 7, 5 is bigger, and then, you see, now 6 is bigger, right? And then, now, look at this. We have this here. We've completely expanded this list. So, what can we do? All we have to do is we just add all of the rest of the other list to it. So now, the only thing left, so now the 2 things left in this list that haven't been added, 7 of course hasn't been added yet, right? because all of these are less than it. So now what we do, we just add those to the list, and we have a bigger sorted list. So, with this recursive call, we can sort it in a very, very quick way. And this is very efficient, and this is why it's used a lot today. It is a bit more complicated than some of the other sorting methods that we have reviewed in this channel, like bubble sort and selection sort, but it is faster, so it is worth it in larger systems. Thank you. This is Neel Kumar. Please like, share, and subscribe. Bye.